All right, so I am a principal software engineer at Viasat, and at Viasat I get to build systems using Clojure, a Lisp. I work with some amazing people, and I also work at a company that does broadband internet from space, so that's pretty cool. I'm sorry? It's the headquarters is in Carlsbad, near San Diego. Yep. So.
Maybe we could try taking it off of the computer. I don't know what else would be causing
Oh, this? Maybe?
that.
Get some echo from this in the mic.
Sure.
If you've seen my nick or heard my name before, it's probably actually in the context of a couple of projects I created called NoVNC and WebSockify, which basically together allow you to do HTML5 VNC connectivity. Okay, so just some introductory front matter. Most of this is actually on the bottom of that sheet that you got. So the goal of this workshop is to learn Lisp by creating a Lisp. One of the sort of principles in computer science or lore in computer science is that one of the best ways to learn a language is actually by creating a compiler or an interpreter for that language. But there's a bit of a catch-22 with that, in that for most languages you sort of need to be a bit of an expert in compiler or interpreter design to be successful at that. But there is an exception, and that's Lisp. And so I think it's a really good learning tool for learning, or a really good way to learn about Lisp is to actually implement a Lisp yourself. And for this workshop, I think you should be able to get a lot out of it if you have moderate experience in programming, any programming language. So if you're here to learn the Zen of Lisp, you're in the right place. All right, so like I said, make sure you've cloned that repository, because that's where we're going to do the hands-on workshop work. So for this workshop, the code examples I'm going to do are going to be in Ruby, JavaScript, and Python. And so I highly recommend that you use one of those for the hands-on, even if none of those are really your favorite language. I think you'll probably be able to get the most out of the workshop, and then after that you can try something more challenging, or try a language that you've always wanted to learn and use this tool to learn that. I found is really effective. All right, so anyways, there's a lot to cover, and I'm going to move fairly fast. I'll try and give at least a few minutes here and there to do some hands-on. You can continue working as I talk. There's also a detailed guide for the make-a-lisp process that I have a link to there that you can refer to afterwards and read through, and it's kind of an expanded version of what I'm going to share in the workshop. There's also the cheat sheet online version of what I gave you, that once you've gone through this workshop, a lot of the details in that cheat sheet will make more sense. Also, there's a Slack channel dedicated to this. I'm not going to be on it during the actual workshop, but I will be after the workshop during the conference, and the plan is to have that active for a week or two after the conference, and I'll continue answering questions if you continue going through the material. And then there's also a more permanent IRC channel at hashmal on Freenode. Apologize about the feedback. I'm not sure if there's anything. Maybe at the next break we can work on it more. All right, so here's the basic agenda. I'm going to start off by giving a Lisp crash course, a 10-minute crash course in Lisp. And then I'm going to talk about the mal, which is my implementation of Lisp, and the make-a-lisp process in general. And then we'll dive into the steps. And so I said there's 10 steps. There's technically 11, although the first one is kind of just a skeleton framework to make sure you can do run tests. And by the way, by step 6, or a little beyond step 6, if you're able to keep up and actually have working all the steps that I've done working in the language you choose, you should have a self-hosting Lisp interpreter by that point. But certainly, if you don't be disappointed if you aren't able to get to that in the workshop. Just continue working on it, ask questions on the channels, and I'll help you get to that point. It's very possible. I'm not going to go into a whole lot of detail on step 7 through A, because just the amount of material. But again, the guide goes into that, and I'll briefly touch on that. Okay, so let's jump right in and talk about Lisp. So Lisp begins and ends with the evaluator. So let's talk about that. Here is a Lisp form. It is, whoops. All right, so add a Lisp REPL, basically a prompt, Lisp read, evaluate, print loop. When you enter something, it attempts to evaluate that. So a lot of things just evaluate to themselves. So numbers evaluate to themselves, as do strings. Other things that aren't a specific data type in the language evaluate to symbols, and are symbols. And symbols, the way they evaluate is the symbol name is looked up in the current environment, which we'll talk about more later. And if that symbol has a binding or a mapping, then it returns the value of that mapping. So in this case, the plus symbol is looked up in the environment, and we find that there is a lambda function, a function type in there that adds 2 numbers. And so it returns just a string representation of that. If you attempt to evaluate a symbol that doesn't have a binding in the current environment, then that'll throw an error. And then there are compound data types. This is how in Clojure and in Mal, I mentioned Clojure because Clojure is really the syntactical inspiration for the Mal Lisp language. This is a vector. It's a vector of 3 items. The first item is, again, a symbol, and the next 2 are numbers. And so when this is evaluated, each element of that vector is evaluated. And so what we end up with is still a vector, but the plus symbol was evaluated, and the other numbers were also evaluated to themselves. And that can be recursive, embedded inside each other, and the evaluation continues through, recurses through all those data types. So in this case, you note that the symbols were looked up in the environment and evaluated. So there's a special evaluation for lists. And Lisp, the acronym Lisp actually stands for list processor. And so when a list is encountered, it has a special evaluation rule. And that rule is that we evaluate each of the elements of the list, and then, well, actually, step back a minute. The way that lists are evaluated depends on what's in the first position. So if the first position evaluates to a function, then what will happen is that the rest of the arguments in that list are used to call that function, and the result of calling that function is what the evaluation result will be. So if I type plus 20, 22 in a list at the evaluator, it will return 42 because it adds them together. It called that plus function. Well, first, it resolved the plus symbol to a function, and then used that function to call with those arguments. All right, and again, just like with vectors, lists can be embedded within one another. And so what will happen here is the evaluator will start evaluating the top level Lisp, the first list that comes across there. It will evaluate the star symbol, find that it's a function, and determine that, okay, now I need to evaluate the other elements. So it will evaluate 2 to 2, and then it will see that there's a list, and now it will begin evaluating the embedded list. And so the result of all this is the internal list will evaluate to 21, and then then star to 21 will be evaluated, and that will evaluate to 42. So that'll be the result of that whole expression being evaluated. All right. Now I mentioned that the evaluation depends on what's in the first position, and it's the normal thing to think about is a function in the first position, but there can also be other things in the first position of a list called special forms or special symbols. And so in this case, I have, and by the way, one way to think about a special form is it's more language syntax. So in this case, in that first position is a special form called if, and if actually does not, when that's encountered in a Lisp, the rest of the arguments are not immediately evaluated. Rather, what happens is the first argument, that true value, is evaluated. True happens to evaluate to itself. And then that if special form says, okay, depending on what the evaluation of that first argument was, then I will decide whether to evaluate the second argument or the third argument. And the reason that's important is because the PRN, that's just a regular function, it stands for print. The PRN function, if it's called, it has a side effect. So if we evaluated if we evaluated true, and then the PRN3 list and the PRN4 list, and then decided what value to return after that, we would get 3 and 4 printed out. And so that's why the if is a special form, is because not everything in that list ends up being evaluated. It depends on other things in the first argument, basically, what the result is. And likewise, if the first argument is false, rather than the second argument being evaluated, the third argument will be evaluated. And so what I'm showing here is that 4 is printed out, and then the PRN functions return nil is the return value. And so you're seeing the side effect and the return value there. All right, there's another special form called def. In Mal, I happen to put a bang symbol after the def just to indicate that it's mutating the current environment. But basically what def does is it doesn't evaluate the first argument, the ABC, because if it tried to do that, there would be no binding for it, and you'd throw an error immediately. So it skips that. It evaluates the second argument, figures out what that evaluates to, takes the result of that, and creates a binding in the current environment for ABC. So after this runs, also def returns what the second argument evaluated to. So in this case, you can see that the current environment after def is run now has a binding for ABC in the environment.
What does the bang mean?
Bound, it's like, what's that?
Def bang.
Def bang. So it stands for define, and in some lists, this is where Lisps can differ. Is how their special forms are named. So in Mal, I could have just used the name define. The reason I put a bang there is because special forms in Mal that actually mutate data, that change something, that they're not just pure functions, they end up changing something, have a bang after them in this case. So, and it's modifying the current environment. You can't see the environment here, but it's making a modification to it. It's creating a new binding in there for ABC. So that's why it has the bang. But it's just one of those things you kind of have to get used to as you look at different Lisps, is they have some of these names that do very similar things have different spellings, use different symbols for them, but they're similar ideas. And I think the last important one that I'm going to talk about is the FN star. And again, there's a reason for the star, but I won't get into that. This stands for function, or lambda, or Clojure. Those are all sort of equivalent concepts, but basically what this does is create a new lambda function, a new closure. It creates a new function type. This special form doesn't actually evaluate any of its arguments when it's called. What happens is that it creates a new function type, and it stores the first argument as the parameter list for that function, and it stores the second argument as the body of the function. And so you can see here what we're doing is we're creating a function that takes two arguments, A and B, and when it's called, it will multiply the two parameters together. So when you define a function, this is just, it prints out the function again. And so we can actually define and invoke that function. So in this case, it's a little weird to look at if you're not used to languages with first-class functions. But basically what's happening here is we have a list, and inside that list is another list that defines a function. That function itself has lists inside of it for the parameter list in the body. But basically, in the first position of the outer list, we're defining a function, a new function, that multiplies two numbers together. And then because it's in the first position of this list, it will then invoke that function using the arguments 6 and 7. And what that'll end up doing is when the function is invoked, a new environment is created, and the values A and B are bound in that environment. And then the body of the function is evaluated like normal, except inside that new environment. And so when it encounters the star, there's a hierarchy to environments. So the star will actually look in the function's environment, not find anything, look to the parent environment, and find that that's a function provided by the system, but it's just a regular function. then it will attempt to look up A and B, and it will find those in the function environment, resolve those to 6 and 7, multiply those together, and return, of course, the value 42. By the way, the reason I keep using, probably some of you know the reason I keep using the number 42. You can Google it, find out why it's such an important number, or not important number, whatever. What's that?
Is that one of those things that determines how old you are?
Good question. Well, I think the book that really popularized the number is valid for all generations. So I think I'm not sure in this case, but that is approximately around the age, give or take 10 years, that I am. So, but that's not why I picked it. All right, so that was probably a little bit longer than 10 minutes, but that was our 10-minute crash course in Lisp. Now I'm going to talk a little bit about mal. Yes?
If you wanted to use that function again without redefining it, like
Yep.
you have a shorthand to it, is it fn star or?
The function that you just created?
Yeah.
So, okay, let me. All right, so I wasn't planning on doing this, but that's a really good question. I should have had an example for that. So what I just did is I created a function, got the value, the actual function type, and then I called the define to create a mapping for that function in the current environment. And now, instead of having to use the literal for that function, I can use the new symbol that I created. Oops, I used the wrong numbers, of course. Hands were in the wrong position. Oops. So like I said, the myFun symbol will be looked up in the current environment, and because we've created a mapping for that in the environment, it'll resolve to the function. The first position of that list is a function, and so it'll be called with the arguments 6 and 7. So, and again, I was just trying to give you a really quick crash course in Lisp so that you have some little bit of context. But as you're going through the implementation, some of these concepts will become clearer, and that's really the purpose of the workshop, is so you learn some of these. This is just an intro, but you're going to learn them more deeply. So, I just want to talk about the inspiration for mal. So a couple of years ago, a colleague and friend of mine, Alan Dipert, he gave a presentation at a Clojure West conference. It was actually a lightning talk. And he talked about a project of his called Gherkin. And Gherkin was actually a Lisp implemented in Bash. And that was basically my reaction. And then right after that reaction, I had this thought. I wonder what other esoteric, weird languages you could implement a Lisp in. And this is a question that a lot of people have thought of and done. But I actually had a language in mind, and I'll share that in a bit. But and it's a language I'm not sure anybody else has implemented a Lisp in, and you'll see why in a minute. But another inspiration is a project called Lispy that was done by Peter Norvig. He's kind of famous in the AI community and in the Lisp community. And it was a very simple Lisp implementation in Python. And so I based some of this on that as part of the inspiration for mal. So before I got to the language I really wanted to try, I wanted to see if I could do this process in a language I knew I was more familiar with. And so at first I did a JavaScript implementation. And then once I completed that, proved that I could, then I implemented it in the language that I actually wanted to experiment with. Can anybody, except Paul, because he knows, but can anybody tell me what this language is? Any ideas? What's that? GNU Make, specifically. It's the GNU Make macro language. It's not the target build rules, it's the macro language in GNU Make. So you're right, yes. It is GNU Make. And originally the name mal stood for make-lisp. Once I did that, I decided, I have a different design than Alan's Gherkin, and so I decided to do it in Bash. Then I did it in C, Python, Clojure, and mal is inspired by Clojure, and so this felt like something I had to do is implement it in Clojure. Don't ask me why. I kept going, did PHP, Java. And at this point, I kind of made an accidental discovery, and that was that Mal had become more than just a make-lisp. It was now a tool for making lisps. And so really, the name now stands for make-a-lisp. So that's what the name stands for. Because it was a tool for me personally for learning languages, for both learning Lisp better and learning other languages that I used to implement Mal in better. And so it was a learning tool for me. I continued, it was sort of an addiction, and I kept implementing Mal in some interesting languages. So PostScript is a stack-based language. I did C#, then Ruby, Perl, Go. I didn't know Go before this. Well, some of these languages already I didn't know, but I learned through implementing Mal. Learned Rust this way, R, CoffeeScript, did VBNet, I know, Scala, did a Haskell implementation, Racket, Lua, and then Camel was an interesting one because it was unique because this was the first implementation that was not done by me. A colleague of mine, Chris Hauser, also known as Chowser, he decided to take this up and do an implementation himself, so he did one in OCaml. And this, by the way, Chowser is also, he's the author of The Joy of Clojure, a book I highly recommend once you've started to learn Lisp, and if you've gotten more interested, it's kind of a drinking from the fire hose of Lisp. It's Clojure, it's about Clojure obviously, but and this marked a transition point for Mal because it kind of transitioned from no longer just being my personal pet project for learning to more of a general learning tool. And it was about the same time that I created the guide, the first sketch of the guide for and started really making the 10 steps crisp. And so since the OCaml implementation, there's actually been more implementations of Mal done by other people than by myself. And in fact, there are now 53 implementations of Mal. And so this is a quick summary of all the Mal implementations. A little crazy. I don't know why I and others did this, but it's kind of addictive to do it once you've really gotten into it and started, and it's over the past 12 months, there's been an average of 1.5 implementations a month, which is just, all right, but enough talking. Let's actually get into it. And hopefully everybody's had a chance to download the workshop repository if you haven't already, but I'm gonna move on. If you do get behind, and likely you will, and you want to focus on the task that I'm currently talking about, the repository actually is tagged for every step. And so if you find yourself getting behind, you can check out the tag right before the step that I'm going to talk about. So for example, if I'm talking about step 3, then you would check out step 2_completed, and that would basically bring you up to the point that I'm going to be talking for the Ruby, JavaScript, and Python implementations. And by the way, when you do this, you'll need to move your code that you've been working on out of the way, which you can do just by moving it, or you can add it and stash it if you know Git at all. Because this won't work if you have things in the place, because it's gonna try and create those files for you. Okay, so let's talk about the steps. So there are 10 or 11 steps. Let's see here. Step 0 is basically just a while loop with a read and a print. And so basically, you read a line of input from the user, you print that line out. And the reason for this step is just so that you can try out testing. And I'm just going to scan through these the diagrams for these steps. And at each point here, the parts in red are what's added in that step. So step 1 is the reader printer, expression evaluation, lexical environments. Step 4 is really several of the first, some more special forms, including conditionals, closures, and side effects. Then we do something called tail call optimization, or tail recursion. Sounds really complicated, but actually implementing it is easier than actually thinking about it, in my opinion. And then you really see what's happening underneath, and that helps you understand it. It's not as complicated as I thought at first when I first approached it. Then there's sort of a grab bag of things that are useful at this point in the process. And then step 7 is some meta-programming concepts, quote and quasi-quote. Then macros, Lisp macros, one of the most powerful features of this. And like I said, steps 7 through A, we're not going to have a chance to go into in great detail, but I will touch on them, and you can use the guide to go through those. I really wanted to get to macros for this, but I think building the foundation for it is more important in the time we have. Then exception handling. And finally, there's another sort of miscellaneous stuff, and this is where the normal mal becomes self-hosting. And for those of you who don't know what that means, I'll get into that. But okay, so let's go back to step 0. All right, so at this point, you need to choose. I would recommend that you choose one of these languages, and hopefully you have got the instructions that said you need one of these. Ruby, JavaScript, or Python 3 already installed and working. And by the way, is anybody doing this in Windows directly? Okay. For those of you that are doing it in Windows, are you going to do it with JavaScript? Anybody? You are going to try and do it with JavaScript? Okay, so there's one thing that I realized this morning, so I didn't really have time to address it, but one of the problems with the JavaScript on Windows is that it actually, the read line implementation there it reads from dev standard in. I can help you at the break if you need some help with that to get around that, or if you want to choose one of the other languages, that's also fine. But yeah, you'll probably just have to wait, and I'll have to address it. There's a module in Node called readline sync that I can use as a replacement. But I'll have to help you with that. So remind me though. Okay, so if you have the repository, you should be on the master branch, and you should be able to, depending on the implementation you pick, you should be able to run this and get your initial REPL to run. And you'll get basically a user greater than sign, and you should be able to type whatever you want, press enter, and it'll just echo it back to you. So just want to make sure everybody's able to do that. Once you've got that working, you can press Control-C, or on Linux OS X, you can press Control-D, it'll exit out of the REPL. And try using GNU Make to run the tests for the language that you picked. So this will just run basically four tests, and I'll show that here.
Is the presentation online somewhere?
I will put it online, yeah. I haven't posted it yet because I was doing updates even this morning, but I will post the presentation, yeah. Let's see here. So let's do that. Okay, so just scroll up here. So this make file, I just ran the test. And by the way, if you happen to use Z shell, you'll need to quote this test bracket, test caret JS caret step 0, put that in quotes because Z shell has special interpretation for the caret signs, and it'll do something bizarre. So what this did is run 4 tests. Each test is, you can see here on the left, it said, I sent this as input, the ABC 1, 2, 3, and got that as output. And so that's a passing test. Test strings containing spaces. Anyways, this is just testing make sure your REPL is correctly reading any sort of string and echoing it out, printing it out. Okay. And if I show you this, so I'll show you the test file too that's used. So in here, in the test directory, there's a test file for step 0. And the way these tests are written is lines that begin at the beginning without a semicolon are the tests that are actually run. The semicolon arrow, that's basically the return values that you should get. This one tests a really long line. Make sure it works. Is anybody not able to run that? Okay. Were you able to run the previous, like actually run the REPL?
Yeah.
That worked, but the test didn't?
Can you show the slide again?
Yeah, sure. you don't actually need the optional for this. I'm just giving that because all the other tests you'll have that optional variable because we're skipping some of the other things we don't need to worry about. They'll just skip some of the optional tests for the more advanced functionality. And capitalization is important. No such file or directory. Interesting. You have the same issue? Really? Okay. All right. So what might work best is if you have people near you that have any experience with shell or make. So are you just make sure you're at the top level in the repository and haven't gone into your implementation directory yet, because the tests need to be run from the top level. And then one thing you can do is make sure if you do, sorry, that's an abbreviation of mine. If you do git branch, make sure that the master branch is marked as being the one checked out. So I do want to move on. I'll try and address. We'll have a break in a bit, and I'll try and address any of these issues at that point. What's that? Python. That's interesting. Why would it be? Okay. Do you have the environment variable Python set in your environment? So if you echo just Python, does that give you a value? No. Okay. Okay. So I think you can get around that by adding. Oops. If you have, do you have Python 3 installed? Okay, so I think you can override the Python version it uses with a capital Python equals and then Python 3.
When I change it to Python,
It just what?
when I change it to the test Python steps or things, but when the JS one will fail out with Python error.
Oh, the JS one. The JS one fails with a Python error. Oh, you know what? I think I know what's going on. You probably do need both versions of Python installed because the test runner script uses Python 2. I think it's intended to support Python 3, but there could be some bugs on there that haven't. Okay. Well, the being able to run the test isn't absolutely critical unless you're a TDD person, but so we'll move on, and I'll try and address as many of the issues at the first break as we can. All right. So let's talk about step one. So in step one, after the new thing that happens after we read in that line of input, what we're going to do is do a process called reading, or parsing the input. So we take that string and we basically do some transformation to that, and what we get out of that is a data structure, an abstract syntax tree. And so that gets passed to our eval function, which just passes it right along to the print function, which takes that data structure, the abstract syntax tree, and turns it back into a string. And so it doesn't sound so interesting yet, but this is a critical functionality that needs to work. So here's just a quick example of this. So we start with a string, and that string contains a bunch of characters. We tokenize that string, and what that means is we split it into the meaningful chunks that are going to be meaningful in a Lisp context. So that string gets tokenized into 5 pieces, and then we do a process that's called parsing. So we go through the tokens and build up the data structure from those tokens. And so what'll happen is the tokens, the beginning and ending token here are parentheses, which indicates a Lisp list. And inside that parenthetical block are 3 additional tokens. The first token, we look at it, and it's not a number or a true or false or nil value or any of the other literals. And so we say, okay, this is a symbol. We'll treat it that way. Then the next two tokens are numbers, and we change them into real numbers in the language we're implementing. And we end up with this this data structure, an abstract syntax tree, which represents a list containing 3 things. All right, so I will actually go and we're going to look at the code for this in Ruby. So after the string is read, we call the reader's read string or read stir function. We pass in a string into this function, and the first thing that happens is we tokenize it into a list of tokens, an array of tokens. Then we check to see if that token list is empty, and what that would mean is that somebody entered a comment on a line, and there was no actual tokens in that string. And then we take the tokens, we initialize this reader object with those tokens, and then call read form. And so the first thing I'm going to look at is tokenize. And by the way, I forgot to mention that most of step 1 is already provided for you. There's a few stubs that we're going to implement, and the reason I didn't not having you implement all of step 1 is because while that's interesting in sort of a language parsing context, it's not really specific to Lisp. This same process happens when, like, you use JSON. You have a JSON string, and you use JSON parse, or you basically it's basically the same process. And in fact, if you have a language that has a JSON parser and printer, you could probably take that code and modify it pretty easily to do this. There's some additional things in Lisp, like symbols, that JSON doesn't have, and the nil value. But for the most part, a JSON parser is very close to this. So I'm not going to go into detail on that. There's a few stub areas that I left for you to implement when we get to the hands-on part. So tokenize, there's a little bit of magic here. A regex that tokenizes Mal's syntax. It looks long and complicated, but mostly it's because it's just using regex symbols, and it's not really as complicated as it looks, but I'm not going to go into it because it's not that important for learning Lisp. But needless to say, when you run this regex against a string, what you get out is tokens, string tokens. So after we have a token list, then we initialize an object, a reader object. And all this reader object does is you initialize it with the list of tokens, it keeps track of that, the token list, and it has a position into that token list that starts off at 0 at the first element, and it has 2 functions, a peek function, which looks at the current token in the list, and a next function. And all that does is look at it returns the current token and updates the position to the next token. So that's pretty easy. Like I said, this part you're not going to have to implement. And then here's the read stir again. So after we create this reader object, we pass it to read form, which is where the real work happens. So read form takes the reader. It looks at the token at the current position. And if it's a parentheses, if the token is a parentheses, then we call the read list function. If it's an end parentheses, we shouldn't have encountered that because the read list function should already have swallowed it. So we have an error. We'll throw an error and stop the reading process at that point. And otherwise, if it's not a list, then we read an atomic value. So let me look at read atom next. So read atom, again, this is Ruby, but the Python and JavaScript side of things are going to be pretty similar. So when we read an atom, we pull a token out of the reader, updating the position, and then we basically match on that token, basically just string match. I'm using some more regex here. This is just matching all numbers and minus signs. This matches something that has a double quote at the beginning and end. And for this, for the number 1, we convert it to an integer. And for where it begins with a double quote, we strip off those quotes and unescape that. It's already a string, so we don't have to convert it to a string again. But we're just unescaping it so that, like, if somebody did double quote, backslash, double quote, you'd end up with a string that actually has a double quote in it. And then if the token matches exactly nil or true or false, we return the Ruby equivalent of those values, which happen to be named the same in Ruby, but in Python and JavaScript they're a bit different, but the equivalents are all there. And otherwise, we return a symbol. If it didn't match any of those, then we just return a symbol. Ruby has a symbol type already built into the language. In the Python and JavaScript side, there's a types file in your implementation directory that has a very simple object definition for symbols that you'll use. And that's already included here for, well, actually, we didn't need to in the Ruby, but, so the only other piece I didn't cover is read list. And this is basically empty right now. Read list, what it will do when you have your hands on and implement this is it will, when read list is called, the current token is a beginning parentheses, so you're going to strip that off. You're going to go until you find the ending parentheses, and for each of the tokens, each of the tokens that you find in that list, you're going to call read form on that and accumulate it in this list right here, and then return it. And it's the equivalent for JavaScript and Python also, which have lists or array concepts dynamic. And so when we switch to hands-on, you'll be filling this in. So let me just show you here. So again, this is how I run tests. I'm changing it to run the test for step 1. So if I run those, there were 21 tests that pass and 8 tests that fail. And this should be the same for you right now before you have implemented anything. And the 8 tests that failed, by the way, so I go all the way to the top of this. It's reading and then printing. Oh, I forgot, I'll show the printer in a minute, but it's reading and printing these values. And so, by the way, this may seem almost trivial and like we're not doing any work, because it feels like we've not achieved anything from the read a little string and print a literal string. But what we have accomplished, what the result of this step is basically a Lisp syntax checker. Because if you have something invalid, it will throw an error. But otherwise, it is constructing the data structure in memory and then printing it out. And so the tests that fail are all the ones related to Lisp, because what's happening here is we expected to send a +1,2 list and get back +1,2 list. But instead what we got back is an empty list because we haven't actually read those values. And so those are the 8 tests. They get printed again at the end here, the list of failures. And so when you've implemented the read list, you should be able to get all the tests to pass. And by the way, if you don't have the tests working, you can still look at the test file. Oops. And find some of the interesting ones and copy and paste those into your implementation to test to see if list reading is working. And by the way, one of the things I forgot to mention, very important, is that you need to implement, whoops, wrong window here. You need to implement read list in such a way that it's recursive capable. So even though I said read list basically goes through all the tokens in the list, if it finds another parentheses in that list, it's going to, you're calling read form. You're going to call read form in the read list. You won't call read atom is the key, because read form has the ability to go back into and read a list again. Okay, so let me just show the printer real quick. So here's the opposite of reading. It's much smaller. What PRSTR does is it takes a data structure, an object, a Ruby, JavaScript, or Python object, which could be a compound data structure, and an optional print readably flag. And then it switches on the type. It switches on what that object is. So if that object is an array, then what it does is it will basically map across all the elements of that array, calling back into PRSTR for that element. And once it's built up that printed all the elements of that array, then it will join that with a space and surround it with parentheses. So what you'll get back is the Lisp representation of a list. If it's a string, in the case where we don't have print readably set, we just return the current string object that we have. If print readably is set, then we need to reverse what we did before, where we escape things so that they could be reread again. But anyways, that's not super important. But the PRSTR is already implemented for you, so I'm just going over so you understand how it works. In the Ruby case, nil, the default way nil gets printed in Ruby is just empty. And so we actually want something to represent that. So if the object we're printing is nil, then we'll print out a string for nil. I'll skip over Atom for now, because that's a different type. And in the final case, we just return Ruby's string representation for that. And that's enough for Ruby. In JavaScript and Python, the true and false and none or null value, you'll need to have cases for, or you will have cases for those in your that specifically cover that. But we don't need to in Ruby. Okay, so, oops. Okay, so for the hands-on, what you'll do is, for the implementation that you pick, you're going to implement the read list, finish implementing the read list, and try and get all the step 1 tests to pass. So for people that are still having trouble, yeah. want to be able to run the tests. The reason Python is used is because the test runner script actually uses Python. Well, I'll let you. I mean, you have enough to go full use. Test going too. That's great.
Use all this stuff.
Anybody else having problems I could help? Oh, you have a full down presentation rather than a workshop. Oh. So it's a similar it's just as job work. You've got the cheat code. All right. Yeah. Sure. So you could which you could load the FS logic and write out probably what I would suggest is just adding the input log and then writing it in. There is actually another. You could just run the file and then for the ones you're interested in, just there is actually yeah. Actually, just a second. So actually, the at 2 in a couple minutes is actually break. So you're welcome to keep working, and I'll help people with it. I'll start up again on the next on step 2 at 2:10 on the dot. So, but anyways, I'll keep walking around and seeing if I can help people with any issues they're running into. So. Basically, what we'll do until you come and then what you'll do is you'll basically then reform. As a result of reform, you're going to accumulate a new list. And then when you get to parentheses, then return that list. Yeah. Yeah, it's not a huge task. I just figured I'd have something for step 1 for people to. Yeah. So. Actually, what I'll do is you can not watch if you don't want to, but I'll do the Ruby implementation of this just so you can see an implementation if you're curious in the couple minutes before the break. Okay. So the first thing I'll do here is just drop the, I know that I started with the parentheses when I came in here, so I'll drop that. And I'm going to loop. And look at the first. I'm doing this kind of in an abbreviated form. It doesn't have to be this abbreviated in your implementation, obviously. So I'm going to loop and keep reading tokens from the reader until I get an ending parentheses. And what I'm going to do is call read form with the reader at the current position, and just append that to my list that I'm accumulating. Okay, and then when this exits, there's going to be a trailing parentheses at the end, and so I'm going to strip that off because that's part of this list that we're reading. And there's one other functionality that I need to have in here for full functionality. So if the token that I got is nil, which will happen in Ruby, it happens when you call next or peek and your position is beyond the end of the tokens. So if I do a read reader.peek and there's no more tokens, then I know I've reached an error because I didn't reach an ending parentheses yet. So I will then so that should be a working implementation of read list. And it's going to be, like I said, a little bit different in Python or in JavaScript, but it's the same idea. So, just so you know I'm not a liar here. Oops. All right, so all those pass without change. Nobody's going to break this. So this is technically break time. I'll just keep talking a little bit about with just some miscellaneous things. But feel free to go. You won't miss anything critical for the next 10 minutes. So like I said, I'll start again with the next step at 2:10. All right. So I'm going to, just so you can have a bit of an idea what's going on here. Let's see here. I'm actually going to capture what's that? Oh, sorry. Okay. Whoops. Oh, yeah. Let's see here. Let's put the puts in there too. So I've added a couple of prints here to print out the what the token list was after we tokenized, and then also print out what Ruby's idea of the abstract syntax tree, the data structure that we parsed. So by the way, if you do this, your test won't pass because the tests look at all the output and we'll see this additional output and fail. So I'm going to run this directly with this debug. Oops. Okay, so when I entered 1, 2, 3, we got a string 1, 2, 3, and then tokenizing it, we got a list of a single token that contains the string 1, 2, 3. And then after it was parsed, it turned it into an actual number, 1, 2, 3, and that's what we printed out there. And then the mal's printer printed out the final 1, 2, 3 to the screen. So if I do a list, you can see that the token stream there is 5 elements after it was tokenized. The parentheses, the plus, the 2, the 3, and the ending parentheses. So we had five tokens. Those 5 tokens get parsed into a Ruby data structure, a list containing 3 elements. The colon plus, by the way, is Ruby's default representation when it prints out a symbol. So Ruby has a symbol concept. And this is what it looks like when you print it out directly. So you can see here the difference between what Ruby thinks the representation of that list is and what how Mal prints it out. So that's I just did that to give you a real quick representation of what's happening internally. All right. What's that? Yes. The debug here or the read list? Yeah. Yeah, I'll just leave this up. I'll stop talking for the next 5 or 6 minutes until the break is over. But if anybody, raise your hand again if you're having any trouble. All right.